Okay, yeah. Hi, everybody. My name is Alex, as usual, and today we have Ivan. Uh, Hello, Ivan.
Hello, Alex, as usual.
Yeah, and our today we have a special guest. It's our friend Valentin. How is going on?
Why you Alex and me is Valentin? Like actually I'm Valentine.
Valentine.
It's
Okay,
yeah, you have the same name in English.
but
Yeah, hey, everyone.
Alexei in English.
Yeah, and you actually Alexei, so like you should probably just say it correctly. And I'm Valentin, so it goes this way.
Okay,
I'm just Ivan.
Ivan.
You like Russian Ivan.
Ivan and Valentine. Am I correct? Okay.
More or less, as usual.
Oh my god! And it's the third episode of podcast. Let me find the name of our podcast.
You can see it's the third one, so like you
No. We have a name. We have a name of podcast. Front Spot Podcast. Third time in Tbilisi with people who don't know how to handle podcast. Yeah, it's a third episode, and today we are going.
I think we need to add one more word. It's irregular.
Irregular.
First time in Tbilisi for people, blah blah blah. Yeah, I think we need to add one more word.
Okay. Irregular front
so
spot
change it, to pick a name, but change a name, it will be more smart move here.
Maybe next time, yeah. Okay. Why not? Like you can comment, you can add comment, and you can create any name, whatever you want in comment, and we will think about it. And today we are going to discuss what? Yes, HTTP. We are waiting for HTTP for 3 months, and now I'm glad to present you our small group, and we are going to discuss HTTP. And my first question, I will address it to Ivan. I believe you can handle it. What is HTTP?
Thank you, Alex, for your question. So, as far as I remember, HTTP means Hypertext Transfer Protocol, and that's just a protocol which helps us to communicate with the server from another server or from a client. And as you see, it's text protocol. It means that the communication is made via network by sending a text. Hope I answered your question.
Yeah, I have a lot of stupid questions, but yeah, probably
one really good one.
Okay.
Yeah.
For Ivan, so like, what was created first, HTTP or Alex as usual? Like, who's older?
That's a good question. Let me think.
I didn't get it. HTTP or what?
Yeah, who was created first, you or HTTP?
HTTP.
I guess you're more or less the same, because like HTTP actually was invented in 1989, and I guess you also did it in 1989.
I'm
so like
so old.
Yeah. So like it's the same age, which is fun because HTTP remains a protocol which we use in like daily, like billions of people using daily, but it was invented in 30 years old, 33, 4, 2, 3, 4, whatever, 4, I guess, something like that. So yeah, it's quite interesting.
But it becomes like a trend to discuss HTTP only for 2 or 3 years after HTTP2. Like we waited.
Initial version was designed back in 1899, whatever, like 89. But 1991 was actually first proposal as a stable version, as 1.0, I guess, something like that was proposed. So it took some time to, polish and discuss different aspects.
Yeah, but you mentioned 91. Yeah, it's
91 is the final version, but
final
initial
version of
is
first
actually,
release. Yeah, and then we waited for 10, 15 years for the second release.
No, second release is actually not release. Second release will be 1.1, which is, I guess, 90.
Okay, I mean, second HTTP second. Yeah.
It's just numbers, whatever. Like you still have React, I know, 0.17, then you have React 17 or 18, whatever. It's just the numbers. It doesn't mean anything if you do it this way.
Yeah, just a small reminder that we were waiting for Avatar for 13 years.
Oh my god.
I wasn't.
HTTP is like things more kind of, I would say, bigger than Avatar. So that's
1999 is its next version, HTTP 1.1.
Okay, why do we need
1999?
I heard about some low-level protocols such as like UDP when we send our data without caring about anything. And if we need to care about data, we can use TCP. Why do we need HTTP?
And also, like I can add, I know that Valentin know about post message protocol, and it's the better protocol as I understand.
What's the name of the protocol? Post message protocol?
Post message, as I remember, no?
What do you mean?
Let me Google it while you are.
Post message protocol?
Okay, while he's Googling, can you help me
it's
to
something
understand
you
why
probably invented?
Why do we need HTTP?
I guess like to understand why we need HTTP, we actually need to understand multiple things, because there is no like short version like why do we need HTTP. First of all, we need to understand what is the protocol. Like what's the protocol and what it represents. Like can anybody ask this question? Have an idea? Alex, you are on an interview, you have a question like what's the protocol?
Oh my god, I just
message.
Google what's the question?
Just give me like what's the protocol? Like what how do you characterize a protocol?
Oh my god, it's a specification where we
No.
Okay.
It's not a specification. Let's say that like specification describes the protocol, right? What's the protocol in the very heart?
I don't know. It's
Let's take some real life examples. Right? Let's not focus on the tech, right? You do have a protocols in your life. For example, you have protocol on treatment in a hospital, right?
Yeah.
Like when you go to hospital, they have protocols how to treat you. So like
okay, let's start from the beginning. First of all, you create, as I mentioned, a specification. Then you implement the specification. You have a request. Like every time when you open your page, you send request. This request contains all of the data.
Yeah, you're trying to explain what is HTTP protocol, but the question was like,
what's protocol in general, right?
Yes, it's not okay. We have another one. We have UDP, TCP. We have POP, SMTP, FTP, as such.
Some structure of the data.
It's trying to wrap different words. Yeah, but like it's very important to understand what's the protocol like itself. Like what's the common between all these protocols, and also you have different other protocols. Like you do have protocols on let's say like message protocol, like message protobuf protocol, which is very high level. It runs on top of HTTP, maybe TCP, I'm not sure. But they all have very like common places, and there's very simple answer for this. Anyone, you have any more ideas?
So from my understanding, protocol is just a set of rules how to communicate between, in most cases, it's about communication between two parts. And having this protocol will help us to have this communication because if two sides knows the rules, then they will be able to communicate. If no, then yeah, you go to hospital and says, okay, I'd like to be threatened, and they say, okay, I doesn't know what does it mean, threatened. Yeah, I don't know this word. I don't care about it. I don't know what I'm doing here. So protocol is just a set of rules to organize all this stuff, and we provide these protocols to both sides, and both sides knows these rules, and when they communicate according to these rules, they have a result.
Sure. So you are almost correct, except you are missing one part which is applied to network protocols. It's not only a set of rules, but also data format. How do you package your data, and how do you exchange this data with other parties? So it's only two very simple parts. It's always data format and the way you exchange this data format. That's it. It's all you need to know about protocols in general. But in the very end, protocols are pretty much different because they are responsible for different parts. For example, TCP UDP, they're responsible for communicating between different hosts, right? And HTTP is responsible for other things, and IP. So that's when people were creating protocols. They have this thing called you probably heard this phrase called protocol stack. Yeah, stack of protocols.
What's the model you mean?
You can name it OCI model. It's a different one. I mean, it's also about stack of protocols. Yeah, but I will probably use a different model called TCP/IP model, which is just simplification of OCI model. And there is actually a question to ask, why it's called stack of protocols? What's stack about them?
Because we connect all of the protocols in one, and the response the same goes from one by one. First of all, HTTP, then TCP, and so on. It's a stack. I guess. What do you think connect? What does it mean? You just plug and play every protocol, and how does it work? Oh my god! It's important to understand. It is important to understand what does connect mean, because you're actually not doing anything to connect HTTP to TCP, right? It just runs. Extend. No. Well, it's there's a small detail which is actually really important. Why our interview because I know change the direction. I can use you as a person who
as a student.
who's trying to find answers for simple questions for me, because actually we can pretty much explain to you. Yeah, what does a connect mean? Give me an idea. All right, I'll probably save you here. So, data. Okay, that's the right word. Data. But what's about data? Go through all of this. How to say specification? All of the rules. No, it's obvious that data goes through all the specifications. Otherwise, it doesn't make sense if you don't send data to the protocols. It's actually called stack because you encapsulate each level of protocol into another level. When you say encapsulate, it means on every protocol, you do have data part. It's actually just data, right? If you take a look on TCP, package format, or UDP or IP, there is a big part called data. Yeah, and data which lies on this format is usually previous package from previous level. So you have levels of protocols, you have HTTP on top, you usually have TCP, you have IP, you have Ethernet, but every data is actually on this level is actually packaged from the previous one. So they kind of stack those. So HTTP goes to TCP, TCP goes to IP, IP goes to Ethernet, and so on. On OCI model, it's a bit more complicated because you have several levels of protocols, and you have 4 kind of categories, like you have application level, session level, whatever. But I'll probably just keep it for now because it's sometimes really hard to understand the difference. And when I was a student, it was really hard that days. Now I pretty much understand like what's the difference between different more like sub layers, but it just doesn't make sense. So yeah,
I wanted to add one thing to this tag protocol. So when I read one clever book when I was not clever student, I remember one good kind of way how can we understand it, and this protocol can be represented as translators, the people who translate one from text words from one language to another, and we need to have several of them, who translates it from like physical level to internet to TCP, HTTP, and so on. And when we send something from one, let's say, computer to another from HTTP, which is on top of all this model, we need all translators on one part and to translate it to very low level, and in another part to translate it from low level to higher one.
I'm not sure if it makes things simpler, but probably just makes sense. Okay, yeah. So like we have stack of protocols, right? And you also mentioned you have very bottom level of physical one. It's actually how you like represent your data on physical level. How do you, if it's wire, how do you, blink with photons to another like part which will understand these photons and convert it to data. You also have this protocol which is Ethernet. I'm not sure what's the name for this level. Yeah, but it's like basically format of data. How do you actually exchange them? Where it becomes interesting.
Is it a 0 and 1, like just a regular, or 0 and 1 a little?
Everything everything is binary, right?
Yeah.
So like it definitely goes to.
Yeah, I'd like to continue this transition asking questions, Alex. Alex, how do you think how 0 and 1s like work? I mean, 0 and 1 and 1s, it's a simple representation of how things works under the hood. But if we're talking about physical level, what is 0 and 1? Yeah, let's say we need to move some data from one computer to another. And
as I remember, it's a signal. To be honest, I missed all of the 5 courses of university, and I cannot remember.
And another one yours in school. And
yes.
Operating only in my preschool, like math skills and the rest.
It's
actually. It's a signal, but usually it's not a signal because signal itself, it doesn't mean anything. Usually it's a change of the signal.
But you can make 0, 1, whatever you want. For example, this one
you cannot make 0. No.
This one will be 1.
Zeros.
And let's
and how to represent it in physical level. You have 2 computers and just one wire.
Okay, in computers case.
Yes, we're talking about.
It's okay, it was started from, I remember. First of all, I heard it when we discussed gamepads, not gamepads, Sega and all of previous game. We use dial-up for connection, and when we call through the dial-up, we heard these signals like, and every signal was a beat, not byte, as I understand, and it was a sound first of all. Sound represented for us this 0, 1, and now through the cable.
Okay, I'm not sure it works this way because if we have a sound, then we need to have a listener to this sound, and in that case, the sound producer should be located near to something that receives the sound, and if it's loud outside, in that case it will not work. So I'm not sure that sound was the way how
Maybe
to
a
produce
phone
the
represented this sound, this line as a sound.
Okay, I'm not that old to know how it works, but probably the sound that you heard, it was just a result of like rotating the disc or something like that. It's not
No,
related.
actually, no. Alex is right. It's actually sound, because sound is not like something very magical. Sound is it's
You know,
some
like,
frequency you
I know
use it,
how-
and you're just using the frequency to modulate data. So when you if you were connected to dial-up and you were taking your phone up, you can still hear like different sounds going on. It's actually network transmission going on the internet. So
I
it's-
have an interesting
no, because
story.
it's just a frequency. Because sound, you whatever using a frequency, you can, when you connect into dial-up using different frequencies, like 40,400, for example, and use this frequency to modulate a signal. And if you just pick a line, you can hear this frequency just modulating.
Yeah, and
So-
sound is just it's just a result of this data, but it's not needed to transmit this data. I mean, if we
It's side effect,
Yes,
it's
side
still
effect,
needed because
yes.
but it's still
But
needed because it's actually
Interesting story, guys.
frequency. Yep,
Your
go on.
previous generation, Ivan, when they would like to copy the game, they turn on TV and
Yep, that's
turn
true.
record, and they record the sound from TV. TV translated this sound of the game, and that is how first game on not diskettes, how we can call it, on a type was recorded.
Yeah, they have magnetic.
Safe icon.
Yeah, but again, you
Voltages.
can you have so many ways to present the signal. You can't even imagine. You can you have pretty standard ones, which is wireless, right? But you can use speed of light. You can use even whatever you want. It's always also about how do you define a data package, how do you describe it. So it's a physical level, right?
Yes.
Jumping next, we do have something called data link level. It's basically representing how do you understand which package goes where. That's actually when we're using Ethernet, if I remember right. It's all about MAC addresses, and how do you communicate different MAC addresses and the data formats and so on. But you are usually not touching this one, two ones, because they are really low level. You never, I guess, configuring your Wi-Fi network or whatever.
And
very hard.
When you asked front-end developer about HTTP protocol and Ethernet protocol and what is a stack of protocol, to be honest, I don't know what you would like to listen. What's the response you would like to get?
There is one perfect question for
I
the
actually were
interview.
asking different one. Yep.
Yeah, it's you open your browser, you click some site, and you click, for example, you texted google.com, and then you click enter. What happens? Next?
Oh my god,
Yes.
it's the most popular question, but not for the front-end developer. For system administrator.
For engineers, it's not for developers. It's
for any developer and
engineers.
engineer. I'm using this question for 10 years to
Oh my
interview
God.
people, because you actually can you have so many topics to discuss.
Yeah,
Anyhow,
but then you need to move your diffs through the desktop, and you don't need to understand what will happen after you click on the enter in browser.
Yeah, but you probably don't need to understand the war, but you probably should have some basic understandings about that killing people will throw you to jail, right? Just some basic. I'm not asking you how much years with if it was performed with a knife or within a group. Just basic ones. Can you just tell me what will happen if you kill a person? You'll go to jail. So the same. What happens when you type google.com in browser? yeah, probably like there's some internet protocols, Google.com, some whatever. Like just tell me what you know. I want to know. Want to
I don't
see
know
how
why I need
deep your
this
knowledges are.
information and how it will help me to understand the candidate, that the candidate will write clean JavaScript code. But okay, after you type any address in address panel of your browser, then you send you request that. Oh my god. First of all, you will take this name and go to your first router in your system. Maybe it will be a MacBook, to be honest, I don't know.
Is he trying to answer like what happens when you try to?
Yeah,
Yes,
so-
yes.
It will take another podcast to record, to be honest, if you want to dive there.
But you asked
Guys,
this
if
question,
you
like,
want, I said that was like very popular question, very interesting one, but yeah, I wasn't asking it. And guys,
and
please.
the best and
put
actual best part,
comments
no, actual best
if you'd
part,
like
you cannot
Okay.
cheat. You cannot cheat this on this question. Like if you will like Google it and like and answer like read some answers from Stack Overflow, whatever, I will catch you because like it's just impossible to cheat because like you have to understand so many levels. So that's a perfect question.
you don't
to
need
ask.
it when you type your JavaScript code.
Okay, that's the topic for the probably next podcast. If you'd like to hear the answer, what happens after clicking enter in your search bar, please put the comments that you want to hear this topic. I hope we'll have at least one comment. And now let's switch to HTTP, switch back, yeah?
Yep.
Yeah, I just want to finish like
Yeah,
with the stack protocols to
protocol.
understand like what's their like need and why is there so many. Yeah, so we were discussing about like physical level, data level, but when it gets interesting, it's actually network level layer. So like when you actually have a network. Problem with a network is actually you need to address like members of this network. Let's say them, let's call devices, right? And like that's where you have IP protocol. IP protocol, it's protocol which like knows about network, and that's where like name IP address coming from. Like every member of this network has unique IP address. There are differences like with like because networks, they are not like networks. Like there's not like one global network. There's a lot of small bubble networks, like within network. But yeah, but like it's whole concept about routing and how do you like route different data and how do you resolve these IP addresses. But like just to simplify, every device on network has their own unique IP address. So that's when I am sending my like package from my server to whatever Google servers. Yeah, I know that I am actually sending this to Google data center because they have a unique address. That's why actually we do need IPv4 and IPv6. I'm not sure you heard about IPv6 because IPv4 is only limited to some number of billions of devices, like 10. I'm not sure. Like,
Okay,
what's
we
the
have
limitation of
2
IP?
in power 8, 4 times it 2 power 32, it's 2 billions.
4 billion, 5
4
billion,
billion.
right? Yeah, something like 5, somewhere between
and
4 or 5
some
billion.
some of these APs are reserved for private networks, for something else, so even less.
Yeah, so like we just at some moment as a mankind we just out of IP addresses, and because like
And-
number of devices is growing, number of servers is growing, number of people are growing. So like 5 or 10 years ago, we actually invented IPv6, which has so many addresses you can even address every atom in the universe, something like that. So it will be kind of enough for us, I guess.
For now, for the next
for
10
couple
years.
for couple of years
Yeah.
at least. Yeah, but problem with actually like we have networking protocol, right, which will definitely get your data from one like device to another device. But on devices, we do actually from some point have a lot of different applications. right? When like there's like imagine like there's a physical wire, you having this data coming to your like laptop because you was able to find your laptop like with IP address, right? But you do have like mail program and browser and you also listen your Spotify music, and they all different like applications. So that's where people were like thinking, hey, how do we find like which data comes to which application? And that's when they invented what, Alex?
You're muted.
No, he's just...
Oh my god, I have two answers, TCP or HTTP.
No. They invented something called port. It's actually called socket. It's actually called socket, but they usually call it like Linux port, and there's whole deviation. But they like to simplify, they actually have port to be unique identifier on your like local machine, where comes what. Yeah, and exchanges like ports and data and do all the transportation. It's called transportation level, which is TCP or UDP is represented. And then on the very top, you also have like application layer, which is like HTTP, which is like whatever you want.
Okay, but why we need port? We can run...
Because like you have only one physical wire coming to your laptop, and there's multiple packets coming to your laptop because they were
you can run
your IP address.
DHCP.
But which package? Wait. Which package goes to which application on your system? Why your browser doesn't receive a package which intended to be packaged to your Spotify music while you're listening? Because your browser and your Spotify they're using different ports to identify themselves.
Just to sort these packages with the right.
Yeah,
but you can run a lot of different servers on your laptop. And
yes, and different servers will have...
You need DHCP
different ports.
Server. No. You need DHCP servers, which will divide it on different IP addresses on your laptop.
Yes,
no?
It will give different IP addresses within your network, but not within your... your point is
you
to have
create your own network.
Okay.
So again, like you cannot use. Actually, I'm not sure. If I remember right, you cannot use more than one IP address for your network interface. It's just a law. Like you probably can use multiple IPv6 addresses, but I'm also not sure. But one Ethernet address, like one network address in your operation system, it should be identified by one IP address. Okay. So you cannot use multiple IP addresses if you have only one Wi-Fi card. You have only one IP address.
Yeah.
So what's next?
That is how we then implemented routers. On routers we have a port forwarding. It's the same like you explained before.
Port forwarding it's a different one. Actually, port forwarding on routers it's a tool to overcome like something called NAT, which is like when you like bubble protect your network.
Yeah,
but it's different. It's actually different ports. I mean, like they're not ports which are opened in your laptop. They are quite different ones.
But the idea is the same.
Yeah,
it's the same idea. It actually takes your like it takes your port and rolls to your like laptop. Right, but there's also ports which are automatically created when there's a connection happening. Like for example, you do have, it's like a whole bunch of reserved ports which you cannot allocate yourself. I guess they're starting from 48,000, something like that, which are allocated when there is connection happening between you and a server, and they just automatically use this port. So
you mean TCP connection, right?
It's part of TCP protocol, right?
Okay, then I have a question. Does it mean that we have a limited number of possible connections / applications / I don't know?
Sure. Like it's limited. Like you only use.
It's tens of thousands.
I guess you have 4 bytes for port number.
Okay, 4 bytes. 4 bytes.
TCP
it's a lot.
It's 4 billions. It's the same number. 4 bytes as for a
Yeah, so it's definitely limited. Like it's not unlimited. I'm not sure like how much.
Okay,
Maybe you have 2
4
bytes.
billions
I'm not
is enough,
quite
I'd say,
sure.
because I
No, it's
thought
2
that
bytes. It's 2 bytes.
then it's 65,000 if I'm not mistaken.
Yeah. 64,000. And starting from 48,000, they're all reserved. So if you would try to start your Node.js server with a port 50,000, I guess you would just fail.
Yeah, my favorite idea, like to start to start my application on 999,000. So.
Okay,
Maybe.
but it's still not clear for me. If we have an application, let's say we have a Node.js server, and we have several connections to our Node.js server. All these connections, they will have the same port. I mean, what kind of port? Will all of them have the
No,
same?
like when connection is happening, if I remember TCP protocol right, they actually start having unique like ports for each connection. So they will use different like ports as a source. There's also to be honest, like last time I was checking this was like 15 years ago in university, so like it was a bit shady in my memory. Yeah, but I definitely can tell that like if you just net start your operating system, you will have like whole bunch of allocated ports starting with big numbers, and that's where actually connection represented. So initial connection goes to original port, but as soon as like TCP shaking is happening, you are actually like allocating new types of ports. But I might be wrong here. Maybe just correct.
Okay, but it means that we have only kind of 25,000 of possible connections, and then articles about like my Node.js server has 1 billion connections at the same time. It's kind of might not be true.
No, actually, it's quite true, and there's limitations also in the operating system how much connections you can have per operating system, and there's also something called multiplexing connections where you can actually multiplex connections. Like you do have one, but you're constantly switching, so it's a different technique. But yeah, I mean, there is no unlimited connections. That's true.
Okay, yeah, actually we dived very deep into this low-level stuff.
I can see Alex is.
And before, I already go sleep. But before we go to the next question, I remember ActivePub post message it because ActivePub use message as a specification for the protocol, as I remember. But I didn't. I cannot Google. On which layer we have ActivePub, like after TCP or after HTTP?
I guess it's even higher. Like it's on top of application layer.
Okay, got it.
On top of HTTP, you mean?
Yeah, it runs on HTTP, but I'm not sure what's the correct name. What runs on top of HTTP? I have no idea. I'm not sure even if it's a protocol. Yeah,
it's a protocol.
Okay,
it's not a network protocol, right? It's a
different protocols, but our topic is HTTP, and maybe let's briefly discuss what actually HTTP, what rules does this protocol have?
HTTP as a protocol, it's a very simple one. You actually do have only 2 parts of this protocol. You do have headers and you do have body. That's it. And like that's simple as it. You do have only headers and body in this protocol.
And may I close our stream and let's go for?
Yeah. Like it's fun because like what makes HTTP protocol to be like amazing. That's why it's actually survived all these years, because it's very simple and at the same time it's open to modification. You can use your custom headers, you can add your like headers, you can use different body formats like whichever you want. You can combine headers in different body formats, right? Depending like if you want to use JSON, if you want to use binary data, and it works. You just need to like to put it on specification, and like both parties should follow the specification. So that's why it's actually like wonderful to as a HTTP protocol.
Yeah,
And it didn't change. I mean, like it didn't change for all these years. It's still same protocol. It was designed in 1989. What changed is actually like what changed is the headers which are required or like standard to be part of this package. For example, if I remember right, host header wasn't a part of specification before 1.1, or method was only like you were only having get, post, maybe put and delete. I'm not sure about put delete. Yeah, but you never had options method. So like it just like what happens like while HTTP involves, it's not a part in HTTP. It's everything below the HTTP, which is quite fun.
yeah, I'd
But
like
it
to
create
some more
additional.
details, about HTTP, because we have like body and headers, but if we dive a little bit deeper, the idea is we have a request and response. And the request is a part that HTTP client makes. It sends a request which contains, yes, it has.
When you're saying we do have request and response, what do you mean?
I mean, in
You mean like
HTTP
server request
protocol-
and response?
No,
Okay.
I mean HTTP request and HTTP response, and each
Yeah,
of
but
them.
there's also headers and body. That's
Yes,
nothing
but
else.
there is some difference between them. First of all, in request we have a method and path, and in response we have also status code which says, okay, that was successful or not successful, or I don't know what happened. That I wanted to it. So we have.
Yeah, like it's like if you like just dive into different headers, there's differences for sure.
No,
But let's say that like
but
can you-
method and pass, it's not the headers. They are not headers. They are
the headers.
nope.
They're headers.
No,
I guess
they-
they're headers.
no. The first line of the HTTP protocol is not headers. It starts from the second, if I'm not mistaken. And the first line has a method.
I can
plus-
see in eyes of Valentin, he started Google.
I guess it's might be true, but I guess it's also I guess first one is you're correct. First one is actually method, pass, and version protocol. So I might be
and status code probably as well is at
Mhm,
the first
mhm.
line. So yeah.
So like just forget everything. Like you have status. You have first line, headers, and body.
Yeah, we will fix
First
it
line
on
can be different for
post-production.
question and response. Yeah.
We'll
But
cut
no
it.
worries. I'm
No.
okay to make mistakes. That's quite fun.
Yeah, but this stuff created additional complexity for us. For example, how we transfer the data in body, form data. Yeah, in browser we have a form data. We collect all of the data and send it to the server. And on the server we like parse it as a just stream. Take this string, parse this string, and that is all. Then we can send a row, we can send a binary, whatever, like, and all of this situation we need to handle, and we need to say, for example, if you write backend application, we need to say we need to create an agreement with our front-end developers that okay, we are going to use this approach. Or am I right?
I guess it really depends on your like what you're trying to do. You can use
But
whatever
you will
want.
not
I watch-
handle all of the possible way to transfer the data.
You will like you who? You a developer?
As
You
a
are-
backend developer.
Again, like beauty about protocols is that you you don't care about them usually because everybody who is making tools for you, like servers, HTTP servers, that's people who are actually very, how you say it, like very depend on specification how to present converted data to you.
Yeah, but
like
we
as a developer,
have
like
content type.
you never take like raw body on your HTTP and trying to understand what a format, right? Usually it's a part of a two-one framework.
Yeah, and moreover, we have two special headers. The first one is content type, and when you send the request, you provide the content type, which represents what type of content you're sending. And the
On
backend
server, you need to handle it.
on
Different
server,
content type.
on server, we have accept header, which says I accept this kind of data. And when it's important to understand that protocol. When you're using some server, you are using this server. You're not kind of creating it. It means that you first check the specification of the API you're going to use, check what data it accepts, and only after that you send this data.
Yes, that is what I mean. Like, we can share just a string, just a text message, and that is all. Why we need content type and different content type?
For simplification,
it create complexity.
but complexity
now
gives
life
us
becomes
some
more easy.
Wait, what do you mean? Like, why it's like, because you have different data formats. Like, you serve files on the binary data, and you serve, like, there is binary in
files
text,
is
obvious
okay,
reasons.
but JSON or string, whatever, like form data.
Like, whatever you want. Like, it
form
does.
data,
Like,
JSON, they all strings. It's just a format that will be easier for backend to read, for example.
Yeah, and okay.
Look, let's start from the beginning. I starting writing endpoint. Yeah, my endpoint will create a user. For creating a user, I need to receive username, user age, user last name, his birth date, his like whatever, a lot of fields, and I need to somehow say, okay, I need this data, and I need to provide a format that I'm expecting to have this data. And of course, I can say, okay, you need to have a string, and the first like 5 letters will be name, then it will be equal, then it will be something else, and so on. But 10 different developers will have 10 different formats. And we have several kind of standards, such as form data, such as JSON, XML, and these standards helps us not invent a wheel, and use some of them. And instead of having this, instead of inventing the format we are expecting the data, we use a JSON and says, okay, we will have a data with the JSON format with these fields and these like data types of each field. That's it. So that's just to make it actually easier, not complex.
Okay, like for me as a front-end developer, it's a little bit difficult to understand in which format I should send the data. I need to call to backend developer and ask him.
How about incorrect one?
How about incorrect one?
Correct one. You just use correct data format. If you want to send JSON, send a JSON. If you want to use text, send a text.
Yeah, but you need to handle it on the backend.
Of course, you will receive a message like the data format is wrong. I don't want
and
to.
I need to try JSON. Then I need to try form data.
Okay, it doesn't work this way. You know what format you should use. Because if you're using some API with a list of endpoints, HTTP endpoints, you probably know
you mentioned the popular way to write application, but sometimes we don't know the API.
When
you don't have a Swagger, you don't have like any documentation.
When you're going to hack, right?
Why some hack? API. When you are going to use any API which you don't have a documentation.
Okay, hope you will. Our listeners will not have such experience working with API that doesn't have documentation. But in that case,
you always can use like very advanced tool for this. Use your mouse. Just go and ask like what's the format. Can you ask? Can you write a documentation?
Yeah, that is what I mentioned. Like I need to ask.
Or even more advanced.
Okay.
Go read backend code and figure out. It's not very hard.
But you mentioned that backend developer can send header accepted or what?
Accept, yeah, it sends, there is a response header which names accept that says, okay, I accept that format.
Or not? Just accept or not? Not to provide the right format. Like I accept only from data.
No, yes, that's how it works. It provides a list of data format that server accepts.
Oh, cool. This one pretty cool. But no one use it, yeah?
Probably.
Yeah, usually you're not using it like in very advanced tools.
Okay, let's move on. To be honest,
we have a list of questions and we 10 of them.
Just one question.
11 and we covered yes, one, what is HTTP? And we spent almost 1 hour, and probably
let's
we can
hurry
move
up
to the next one. We have HTTP 1.1, we have HTTP 2. What's the difference? What's new?
I know only one, that as a front-end developer I don't need to create a sprite for images, and I just can upload it, all images in a lot of different requests without any sprites, and yeah, just to storm your browser with the requests.
It was a question for me. Sorry, I just missed it. So
no, it's a question for us to discuss it. Different between HTTP2
the question is,
and
what's new in
HTTP3.
What's new in HTTP2? And Alexei mentioned that actually I didn't understand like the problem that was before.
Before you should take all of your picture and create one sprite for all of them.
Because you wasn't able to send several pictures.
Yeah, like so there's different phases on HTTP protocol itself. Very first version, like 0.1.0, actually for every request you have to open and close TCP connection. And TCP connection, it's quite heavy to open because you need to do like back and forth and back, like 3 handshakes. So it's like round trip and one more. And also like you also have to send, like it just, like if it takes, let's say, half a second, like round trip, it actually takes 1 second to prepare to send the file. It's not about sending the file, it's only about preparing to send the file. So on HTTP 1.1, they actually allows you to keep a connection. Like you can keep connection and you can send multiple requests using the same TCP connection. But the problem with its keeping connection is actually if we will open, as we mentioned, you have limitations on number of connections. And actually connections are very heavy from a server perspective. It's really hard to keep them opened. So if you will open like unlimited connections on your server, right, it will be quite messy because you probably will take server down. And it will be very easy thing to do DDoS. So even on HTTP 1.1, there's ability to keep a connection. Like all the browsers were actually limiting number of files or number of maximum connections from one browser to one domain. For different browser, it was different number, but like it was somewhere between 4 and 8, I guess. I remember like for Chrome it was 6. Like you just downloaded 6 files and you downloaded another 6 files and so on. So biggest change in HTTP2 was that it's actually allowed to download multiple files simultaneously with the same TCP connection. That's why you don't need to like build the sprites and the rest. You only just open one TCP connection and you have like in the protocol itself, you just downloaded like files. But fun part is actually HTTP2 it's a binary protocol. They use a binary for compression and for just saving bytes and so on. So that was one of the biggest changes on HTTP2, I guess. Compression.
Yeah, probably we need to change the name. It should be HBTP because it's no longer text protocol.
No, it's actually text inside of I guess of data, but they just some packaging this some way or another. I'm not sure.
Yeah, but we
I'm
can,
not
we
sure.
can
Like,
send a file, and the file will be sent not like a text, it will be sent like binary data, right? It's no
what do
longer.
you mean?
I mean,
Wait, you can like it's not about data. About how do you like communicate as a part of this HTTP.
yes, because in HTTP 1.1, you was not able to send any binary data. You was able to send only text. But starting from the second version,
It's the difference between binary data and
Yeah,
text data.
it's just
Every text
the
data
same.
is a binary data.
Okay,
Just the format.
why then HTTP is text protocol? Because the body is just a text.
Yeah, it's a fun part. But there's two types of protocols. There's text-based protocols, and the binary-based protocols. And text-based protocols, they're usually less efficient in terms of data, like you're using more data, but at the same time, they are more efficient in terms of like debugging, playing around, maybe operating, because you just can use, simple grep tool to find something in your packages. But yeah, binary is just different one. So it's just more convenient to develop with the text protocol. Yeah, but you can definitely use like send binary data with the text protocol. It's not like illegal to do it.
Yes, and starting from the second version, you can do it. Before you wasn't not able to do it.
Then you can do it with the first one. Like you can use content type application binary stream and use witness stream binary data. I'm pretty sure.
I'm pretty sure that you was not able. You
it
are
will
not
be
able.
encoded differently, but like why you cannot send binary
Because
data?
it's text. You can provide only text. Of course, you can transfer your binary data into text.
Okay.
But it will be text.
Wait. You said of course you can send your binary data in text, but you send in binary data.
No, you send in text in that case. That will be transferred.
No, it's sending binary data in text. Whatever.
No.
Text is just number
Oh
of
my God.
symbols. So it's just encoding and decoding. So you
It's
can
the
definitely
same
do
text and
binary
binary.
data. Like
For me, it's the same.
What you are saying actually, you're saying that like before HTTP2, nobody was allowed to download a music, but you were basically downloading the music when you was young, right? And it's binary data.
But it was transferred to a text. It's like if I understand it correctly, for example, for
And
images.
what is text?
For images, it's like base 64, for example, format. You can provide a format for images as a base 64, and in that case, it will be text, but it will be much longer.
I guess application binary it's from very beginning as a part of protocol. I'm not that sure,
Okay,
but I like 99% of sure.
Yeah, anyway, even if we send binary data for HTTP headers and all like organizational stuff of this protocol, it's still text, and in that case, it's still text protocol.
Okay, I understand only as a front-end developer. I'm sorry, guys. I understand only about limitation of connection. Now limitation was extended, yeah, or there is no limitation at all in the HTTP2 for connection.
What do you mean like limitations?
I mean, previously we discussed that it has a limitation. It had a limitation for connection to OpenTCP.
Oh, like every when you open website or like, I'm pretty sure you probably still have limitations of number of like connections, because it's still heavy operation.
I agree.
But again, like right now you just need less of them. You need one connection to download multiple files in parallel. Before that, it wasn't possible. You can only download 6 files for Chrome, for example, in parallel. So that's it.
Okay, and also you mentioned something about encrypting, or what?
Yeah, actually, HTTP2 it's when like reality hits specification. So like on HTTP2, for example, you basically can use this protocol without any encryption and SSL. Like it's in the protocol, you can use plain unencrypted data. But in reality, when browsers, servers were implementing the protocol, you will not find any implementation which doesn't use SSL as a part of HTTP2 handshake. So like it's a one problem. More fun problem is that you do actually have as a super invention on HTTP2 this mechanism called server push, when you actually can push data from a server to a front end. Like it's not a WebSocket, it's just different one. You have special headers and there is a special formats and transforms. But it feels like these days nobody's using it. So
also just read an article that Google is removing this feature from
deprecating, deprecating, removing. So it's fun because it's in the protocol and you kind of can use it, but since it doesn't become any popularity, they just dropped it. Yeah, so like there's some minor parts in HTTP2 which were designed, but they were never implemented. Like it's always SSL, and we don't use server push anymore.
Okay, you mentioned SSL, but okay, what is it? We have a handshake between our HTTP connection, and where is this SSL?
When connection is established, like once you have a confirmation this connection is established, you start doing SSL handshaking. I guess it takes also 2 or 3 handshake, like going back and forth to exchange private keys and confirm that like you are trustworthy to do it. So like that's like since
I have
SSL the user
private key.
No, like every site has a private key, and also they have a public key. So like they just exchanging. I don't remember like exactly how the protocol works, but usually they giving you data, you usually sign in this, and they giving you public key. You using public key to sign in data, and using your public keys, and they kind of exchange it, and they confirm that they confirm that everything is correct.
No. I am not asking about how public and private key works. I mean, like we have a SSL and we have HTTP. I type google.com. It create connection.
Don't go this way.
Okay.
Yeah. Okay, you want ask what you want.
When and how I take
after TCP,
private
after
key,
TCP handshake,
public key,
after TCP. First you have TCP handshake, then you have SSL handshake. How many data round trips it will take for SSL? It depends on the protocol. There's TLS 1.1, 1.2, 1.3, and they're using different number of handshakes. But to start SSL handshaking, because it's like more high level protocol. TCP is a session level, transport level. I guess it's transport, right?
I don't understand who approved my handshake. Like I request the data.
Who approved? Like what do you mean? Who approving your
public and private key? We need to connect this in between each other. I don't know how it works under the hood, private and public key, but some of this chain, like me and site, some of us have a public key, some of us have a private key.
Both of you have
both of you have
2
public
pair.
and
You have your public key and your private key, and the site has its own public key and private key. And when the connection is started, you create the data you encrypt the data by using site's public key. Public key is used to encrypt data, and all this encrypted data
browser under the hood encrypt the data.
It depends. Actually, HTTP is not only about browser. The client uses public key.
Client, okay,
if you're talking
client.
about sites, it's browser. Yeah, browser uses public key to encrypt the data. Then this data is transferred through network in a encrypted way. And we cannot read anything. Sites like server receive this data. by using private key, it can decrypt it and get the data, and then by using your public key, it encrypts it again and sends it back to you, and you, by using your private key, can decrypt it. That's how I understand it works. Probably I'm wrong.
No, it's very close, but you also have this certificates which needs to be confirmed with the, like there's a chain of certificates and you need just to confirm that they are valid. With
and who validated?
Your operating
Special
system.
service. No, there
Your
is.
operating system, and you have you have services which are responsible of confirming that this certificate is valid.
Oh, okay. There is a service.
Like for example, on your operating system, there is bunch of certificates which are just hard coded, and you're reviewing them every another month or whatever. So certificates world are quite complex.
Okay, that is how HTTPS works, yeah?
Yes.
It's how SSL works. HTTPS is actually HTTP plus TLS, and HTTP2 is actually HTTP2 plus TLS, but in reality it's always HTTP2 and TLS on top of TCP. Yeah, and it's important to understand that HTTP2 is only using TCP, so you have to every time you connect somewhere, you have to go through this TCP handshake mess. And for example, if you let's say living in Georgia and you have a website which is hosted in California,
or in Georgia, but another Georgia.
I guess California will be more realistic, because I guess going from Georgia to California, it will probably take somewhere around 400 milliseconds.
But we have
one way.
We have one more example when you request the data from Georgia to Georgia, and it will take also a lot of time.
Is it some government regulations or what?
Georgia, it's it's a state or city?
Valentin understood this joke, but his point that California is more far from us and it's better example.
Yeah, I didn't get it.
Yeah, I got the idea. But I mean, if it's going through borders and going with a Russian firewall, it's still quite near you. But California, if you want to really speedy internet, everything is high bandwidth, you cannot cheat physics, right? It's always no faster than speed of light, and California from you is somewhere around 6,000-7,000 kilometers, so it also takes milliseconds. So when you're doing TCP handshake, it actually will take you going one way 3 times, which is 1.5 seconds just to do connection.
That is why my server in Dota, which located in America, have huge ping.
Yeah, more or less. Ping is actually very representative of how much it takes your package to reach some server.
Okay, we finished with HTTP2, and I don't know why, but next protocol HTTP3. And what's the difference? We already have these amazing features with connection, with encrypting data. We specify that, okay, now it works like this. And then HTTP3. Why and what's the difference?
Because a lot of people were discussing this for many years, and I guess general understanding is that TCP is just a bit outdated, because again TCP was invented 40 years ago, 30 years ago. It was different world. We didn't have mobile phones. You have to use this dial-up models, whatever, or even worse equipment, right? And that's why TCP was important because you all like every time you have to make sure that your connection actually like healthy, that you reached your recipient and so on, right? Because like equipment was shit, like the routers were shit, like everything was shit. But these days you have really good tech, and like making these TCP shakes doesn't make any sense because like how many times you like they failed, how many times you failed to establish connection. It's probably like 0.101% of all the packages, right? So but it also like when you like using websites, you browsing a lot, it actually takes good amount of networking just to do the handshakes, which is kind of crazy. Yeah, and we have a different protocol called UDP. It's just very simple one. Yeah, it's one-way communicating protocol. You just sending data from one side to another. It doesn't have all this handshaking. Just send package without confirmation, and that's all. And by using this very simple protocol, which is pretty well known, it was released the same years and days on TCP. You can implement your own protocol, like even if you want confirmation, which will work better than TCP. And the whole problem, like in the world, that you cannot invent new protocol and call them Alex package protocol and say, hey, we have new shiny Alex protocol, which is super advanced. It does consider all the all the pitfalls and all the features, because we have so many equipment like on data servers, on user devices, and they already know TCP and UDP, and that's it. You cannot update all the devices in the world and let them know like there's new protocol. It's just impossible, right? So they have to use something which exists, and UDP is a pretty really well known and pretty simple. That's why they actually invented HTTP3, but HTTP3 it's basically HTTP2 on top of UDP plus several features. Yeah.
Actually, maybe a better way to say it's like on top of Quick.
It might be like correct one, but again, like if it's different levels, right? UDP is it's a transportation level, so like it's how do you deliver packages. Yeah, and Quick is actually implemented their own protocol. How do they change these UDP packages, right, in order to achieve your HTTP exchange? How do you say it correctly? Yeah, so Quick was like part of experiments which Google was doing for
Okay. It means we started with please don't use UDP your packages. We can lose your packages, and now we return to this UDP. And at this moment, when I type google.com in address bar and send it, I'm not sure whether the server received my information or not.
Actually, from what I understand, they actually reinvented TCP, but instead of adding a new version of TCP, because like Valentin said, it will be hard to update all software, hardware even in the world. It will take decades. They used a very simple version. Almost UDP is even like nothing. It's not even a protocol. It's just a simple way to send data. And they, on top of this stuff, they created their own protocol. And with also confirmation that the data is sent, so it means that no, you will not lose this data. They reinvented a TCP-like protocol on top of UDP just because it's easier to implement.
Yep, pretty much, and mostly because you actually need this for browsers and maybe some other devices. So yeah, it's easier, and you can like add more and more experiments. But like transportation protocol will be UDP.
Okay,
so, which is kind of fun.
Maybe you can give us some kind of not features, but maybe some benefits of HTTP, what it gives us when we use it.
HTTP3, you mean?
Yeah, HTTP3.
Again, like I even not sure like these days what the percentage of coverage of HTTP3. I'm not even sure like if Nginx released the HTTP3 support yet. Yeah,
Yeah,
but
I'm not talking about features. I mean, let's say
yeah, but again, there is some design for some features which like was announced, but nobody knows it will be adopted or not, and we will see. I guess like main part of HTTP3 is actually that like on Quick protocol, you do have TLS as a part of protocol, so you don't have to do handshaking. You actually getting this for free, not for free, right? But like out of the box. And fun part is actually that like before, like on HTTP2, you don't encrypt some parts of packages. I guess you don't encrypt headers right now. Like you cannot hide, certain areas of your like protocol. On Quick, you just basically have very advanced.
I'm not sure that we do not encrypt headers. I'm pretty sure we encrypt headers, and moreover we encrypt even.
Which headers? Like because there's multiple headers. I'm saying about TCP headers.
TCP headers. Okay.
Yeah. We don't. I guess we don't encrypt TCP headers, but on Quick we only expose like a couple of headers, and the remaining is actually encrypted, maybe. Which is quite part. Yeah. That's the one part. Also, like what's really exciting about the HTTP3 is actually they invented something called connection ID. Problem for TCP right now is actually you like unique identifier for every recipient is combination of IP address, network, interface, I guess port. I guess there's three components which are unique for your identifier. And like it doesn't represent reality, but because in reality we can have our podcast to be recorded on StreamYard, and then you just transfer your recording to your phone and you want to continue. Or you just connect on your VPN and your like IP address is changing or like port is changing, and it just never like you have to reconnect all the time. But with the connection ID, they actually promising that like that unique identifier for your connection will be not like this port IP address, but just some connection ID. Which means if you change the network, if you will go from Wi-Fi to like 4G, 5G on mobile phone, they will be like available to keep a connection, not reconnecting one.
I remember
which is super cool.
We discussed already cool. This feature. It's I'm waiting for it because it's so annoying when you change your Wi-Fi and you would like to continue watching video, and somehow application don't implement the auto refresh or auto reload to the server, and that is all. Like it stopped and you cannot continue. But as I remember, for example, Netflix have a reconnect method, which like when you change your Wi-Fi, for example, Netflix send request again and again, and it.
Yeah, but they still have to reconnect, and they have still to do like new TCP connection.
Yep. Yeah.
Right. Well,
yes.
It's just because how it works. So like in theory, it will work differently on HTTP3 and Quick. There's a couple minor ones. Like they also saying that like, there is like multiple data streams which will be available to be multiplexed, which means you can basically like right now when you downloading all files on one TCP connection, there is no priorities. You cannot say like which file is more important. It's just downloading which one first. Like when it first was downloaded, they will download like this earlier and so on. But on a protocol level, we do have actually ability to prioritize this like traffic, and also I guess just have different like byte streams. So like it's not like they just package different files on the package, on a quick package, and send them all. They can actually have like some differentiations, like which file is part of it. I'm probably just awful describing this feature, and I'm
Moreover,
to be honest, I'm not sure like what will be implementation.
Yeah, I wanted to add about the feature you mentioned about this multiplexing stuff. In HTTP2, we have one single connection, and if we send several data streams within one connection, we might have a problem when, for example, we have one connection and several kind of requests within this connection, and if one package is lost for some reason, and we tries to get this package one more time, because TCP is when we are sure that the package is received, and until we get this package, all next packages will not be received, they will be stopped. And that's kind of a problem of HTTP. Not actually a problem, but a small issue. Yeah, if some package is lost, the whole stream will be stopped. And this kind of an HTTP3 version and the thing that you mentioned, this another way how this situation is handled. Yeah, and even if one package is not received, it doesn't stop the whole data stream.
Yeah, I'm agree. That was one of main pains to be relief.
We have all of these features, yeah, and as I remember, we discussed it with you a year ago or before war started about this feature with the Wi-Fi, but it's still not implemented, as I understand, yeah.
Because it will be really hard to implement, I guess. Like, can you imagine like the amount of work you need to get done in order to apply this protocol like worldwide? It's just insane. My estimate, it will take like 2-3 years at least to have a good coverage, because you have so many members of chain needs to be changed. Even like network providers, they need to change their configuration to allow UDP, because for some network providers UDP packages just they just permitted, you cannot send UDP. So
oh my god, it means like this it's just as we started, it's just documentation specification, and it may
it's
not be
it's not documentation already. No, it's not documentation already. For example, on Cloudflare, they have this HTTP3 for like, I don't know, a year right now. You can just enable it and they will...
Cloud what?
Cloudflare.
Oh.
If you never played with Cloudflare, you should try it. It's like one of my favorite tools. It's basically CDN, but they have like so many advanced great features.
Okay, I know.
I guess Nginx
I have
should be released in like HTTP3 already. HTTP3.
I have googled a bit and I found an HTTP3 Wikipedia article, and it says that HTTP version 3 is supported by 75% of web browsers and 83% of tracked desktop web browsers, and 26% of the top 10 million websites. So it means that it's actually started to be used, and probably in
but
1 year.
As Valentin mentioned, we need to change our network. For example, I understand that some providers...
Like HTTP3 in general is supported, but like, do they have this connection transfer feature? We don't know. We don't know.
We don't need this. It's only needed to have a UDP, and both client and server should support HTTP3. I mean, it says also that it has been implemented by Chromium since April 2020. It means that for 2 years, if some site has HTTP3 support, you are using HTTP3, and probably you already used it by some websites. And the brilliant case here, the brilliant kind of feature of this HTTP3, that it's not needed to be supported on middleware devices, because it uses for those devices is just UDP.
Yeah, like everything's complicated. Like you can say that HTTP3 is implemented, yeah, but like does it fully implemented? It's a question. You can make a basic implementation,
What
but
does
drop
it mean
some
basic?
parts.
I think
No, actually, no. Like it's actually a very like good one. You can definitely have a basic implementation and drop some features. For example, nobody will die if you would not handle byte multiplexing, right? Like you can just pretend you have it. It's one part. Second part, it's already networking. Like you have to do networking right. And with the connection ID, you actually need the whole chain of routers to understand what the connection ID.
no,
And when you're reconnecting,
you
you
don't
do
need
need.
it. No,
You do need.
you need
You
it
do
only
need.
you need only on client side, because this
No.
connection thing is on client side, and all middlewares, they don't care about that. The thing is about creating a connection. Your middlewares, I mean routers, they doesn't care about your connection. The connection
They
thing.
actually very do. They
No,
actually
no.
very
Look,
do.
you have this combination that you mentioned of like IP and all this thing, and when you switched your internet to 5G, for example, your IP address is changed, and you send the request to your server within this with this new like IP address but old connection ID, and server says, okay, I'm sure that you are who you are. I know this connection ID, so I don't need to create a new connection. And connection already exists. And middlewares, they don't care about that.
You might be right, but as far as I remember, when you send in this connection again to the server, like there's my connection ID, right? You need to be forwarded the same way as you were doing this before.
Yeah, but the server IP
Because
didn't change.
you need to pick this connection. So like the whole chain actually needs to pick your existing connection.
Nope, UDP doesn't have connection.
UDP doesn't.
guys.
Yeah,
Quick
but
does.
You can take your phone and click A if you agree with
Can we mute
Ivan,
him?
and
Can
click
we?
B if you agree with
He's a host.
Valentine.
Yeah, when you send some data for middlewares, is just UDP. That's the killer feature of HTTP3. Your router doesn't know that you use. Actually, doesn't care.
But again, like is UDP true? Yeah, but you actually have a different UDP stream back.
Yes,
Yeah,
and that's why
it's UDP.
That's why you need to have this implementation only on client and server, not on middlewares. Middlewares UDP, client quick and server quick.
It might be true. I mean, like what you're saying, it makes sense, but it's how I thought it should work. But I also was, discovering some parts. I don't remember what the details was, where that it's not that simple, and that actually like forwarding these UTP packages will take some resources, and that's why it doesn't work these days. Otherwise, like we all struggle from being disconnected. And if you're saying 80% of websites are using HTTP3 already,
nope,
yeah,
not 80, 26% of top 10 million websites.
Whatever, 25%, 26%. Yeah, we still struggle, and I never seen connection. I never seen connection.
We can test it as a homework.
I tested this every week, 10 times.
Every day when I
maybe every
go
day, because
through different rooms.
Yeah, it always fails.
My Wi-Fi. Yep.
It always fails.
And if you're smart, you can write a comment in our YouTube channel, and please vote. Valentine is a B, and Ivan it's a A.
Can we comment?
Yeah,
you can already type a comment on YouTube, and you can choose any. No,
I'm actually agree with I would like in theory, but in practice, I'm trying to find a way why it actually was failing at least in the initial implementations. But I can just
Okay, you can
a bit
easily check
later.
it. We can easily, not now, but later, like check what site supports HTTP version 3, check if our browser supports, but probably if you're using Chrome, it should support, and then connect, check a network which connection is used. If it's HTTP version 3, then switch off your Wi-Fi from one to another one, check it, or
You can try it now. Change your Wi-Fi.
It takes time. But we need
No,
first
just
check.
change your Wi-Fi.
Okay, changed. Oh, nothing changed. Okay, it looks perfectly fine. It works perfectly fine. Oh my god, that's perfect.
Okay, guys, I
actually got.
I checked.
I have probably understanding why it doesn't work.
It's HTTP3.
Problem.
I just checked. I just checked the network and Google API's storage. I see some requests to Google API storage, and it uses H3, which means HTTP3.
Google using HTTP3, yeah, for a long time.
No,
yeah, it's storage googleapis.com. It's some Google APIs, but that's cool. And upload that goes to StreamYard.
You mean our
HTTP2.
platform?
I opened this StreamYard network, and I see some requests to Google APIs, and it uses HTTP3. Yes.
So you know what's the problem about like connection IDs and transfers? Load balancers. Like you actually need to go through load balancer, and with this connection ID. You ideally you want to hit the same server as where you were before, right? Because
not
this way actual connection. Imagine we're talking right now on a video, right? And we do have connection. Like imagine we're using HTTP3, right? And we do have this quick connection to some server which actually processing the video, right?
Okay, but
and
HTTP is not used for sending real-time video. And when we're talking about HTTP,
whatever, like you listen to music, whatever, you can use HTTP3 for such
it's still
things.
streaming. It's not about HTTP. I mean, HTTP is stateless protocol. The idea is every single request is independent, and that's why when you make requests,
just drop HTTP. We isn't quick, right?
But
quick can
is a part of
conversations.
HTTP. Yes, but
no, quick is not a part of HTTP. Quick is a quick.
Yes, but it's
you can
not
use
used
quick separately
for streaming. It's not used for real-time data.
I guess you can use it for real-time data. Why not?
Yeah, but that's the problem. Like if you used it, it's not. It's a bad example.
Valentin.
I mean, stream like real-time video is a bad example. So just a regular.
Why?
Because real-time data uses I don't know, WebSockets, WebRTC, whatever else, but not HTTP. It uses UDP under the hood, and it has its own things. It's not quick.
What's the WebSocket? I guess it's running on TCP.
Maybe, but
yeah, I guess there's no WebSocket protocol which they all running on TCP or UDP.
Okay,
that's
then
WebRTC. So which means even if we're using WebSocket, we can use quick with WebSockets, for example.
Look, WebRTC for real-time data, TCP is not used. Maybe then I was wrong. Then WebSockets it's a bad idea for using for real-time communication, for example, for games or for our conversation right now. But HTTP, a typical use case is online shop. Yeah, let's say or Facebook or Twitter. That's a typical usage of HTTP. And if we check that, it's
correct. If we you probably will agree with me. If you're using websites and you switch network, you don't fucking have any problems. You just reload the page and you're done. We are talking about something which is real time, talking on the video.
And that's not
let's say watch it
HTTP.
No, wait. It's something about transfer protocol. It's always about transfer protocol, which is quick.
Nope. That's the reason.
Like quick.
Because-
Like where's the definition? Quick is a transfer protocol.
Yes.
Okay, so can we use quick for transferring video? So like, can we use feature connection migration to
Yes.
transfer video? Okay, you were saying that you cannot use it. We can use it.
Okay.
We're not using it yet.
Can
Yeah, but
I
like,
ask you the question?
no.
Got it.
Go on.
If we use if like let's imagine ideal world that connection ID works perfectly. Yeah, it doesn't have any issues. Then we will use Quick for our online communication, real-time communication. How do you think? Will it work fine? Will it work better?
But then what? Then
Better than existed one like WebRTC or like I don't know raw UDP with some additional things.
I'm not sure about what's under the hood of WebRTC. What's under
So
the hood
the
of
problem
WebRTC?
is it's a different use cases. For communication, we don't care about packages. If we lost them, we don't care about that. UDP and Quick as well still have confirmation, and it's important to receive all packages. And if we have a small interruption of connection or whatever else, if you're using some TCP like, it can be TCP or it can be Quick.
But WebRTC is using TCP or UDP. It's your choose. So like WebRTC basically using TCP. I just Google it. Just Google it. WebRTC can use or TCP or UDP. So what's the point?
Okay, then Google how to use TCP with real-time communication. So the point is for our communication, UDP is used because we don't care about lost data. For HTTP, we do care about lost data. It's a different use cases.
No, we're not talking about HTTP right now. It's like it's not my area of interest. I just want to use protocol which can migrate me from one network to another in my network.
Yes.
Right, for let's say binary data.
Okay.
Not a real-time data, binary data. We say I don't want to see Netflix saying, "Hey, like you switch to different Wi-Fi, please like reload my page." It's a shit. If I switch in from Wi-Fi to 5G, I want Netflix to understand like, "Hey, I'm still having this connection ID, and I can buffer this like something I'm watching right now from the same server for same connection ID." It sounds possible for me.
Okay, for Netflix, probably you're right, because Netflix is not about real-time communication. I think
you can
Netflix
also
will work.
do the same for Zoom. Yeah, it will not be perfect transform. Like it will not be perfect. You will probably have, let's say, half a second delay because it will never be real time. But again, even our communication right now is not real time, because if you know how like video communication is working, they sometimes changing the frequency of audio and video just to speed up everything, or just skipping some parts.
Okay, that's another
so
question.
they're always trying to to be aligned of something like we call real time.
I don't agree here. It's a real time communication because real time is the way how you understand it. I mean, you're a person. You have some delay between you until you understand that that's not real time. The point.
It's never real time. Like I mean, like it's
okay.
It's like,
technically, it's not real time. Yeah, but for you, it's real time.
I even sure like that like my picture is like behind me for like couple of seconds, because right now I'm because it's the usual predatorize sound out of the picture.
Look, when we are talking in real life between each other face to face, it's still not real time, because we have time until your sound that you made will come to my ear. Oh my God. Right? And the difference.
I mean, like it's a really well known fact.
Yes, and the
problem
point
that
is,
I have to go in 10 minutes.
Okay, we still have no problem. The point is, it's like 2 seconds. It will be too much to and
yeah, it will skip. But I don't want like this like hey, we're reconnecting, please wait, it might be reconnecting, we will not and it's what happens for all modern like tools like Zoom, whatever you want, like Google Meet and the rest. So I just want this to be better, that's all.
Use HTTP3.
Okay.
You were saying me that
No,
HTTP3 is
I
like
say to
have no deal with like video communication. Now you're saying the opposite.
No. It's like a conclusion. Like use HTTP3. No, it.
Use Quick for that. Like it's not HTTP3. You don't need HTTP3.
You use Quick for what?
Use Quick for your mom.
Nice conclusion. Okay, guys, use HTTP3 for whatever you want, and use Quick for whatever we want. That was our podcast, and I think we can finish.
No. About future plans. I understand that I don't have any ideas about future plans of HTTP. Like previous one was like magic for me. HTTP2 magic, HTTP3 magic. Maybe you guys have some idea for the next protocol version, like which issue we can solve in future.
Well, actually, there is so many like I guess they will be more or less experimental, right? But like beauty about Quick that you actually can, let's say, like release new features quickly. You don't have to wait 5 years to try something out, and like every day there is new like researches publishing, which like if it sounds like somebody increased data efficiently by 1%, even 1% sounds like 0.01%. If you multiply the whole world, it's just insane amount of data and CPU power and so on. So I guess they will just do a lot of well experience of how to behave on different networks. That's the future, but we don't know what it will be.
Is it a science or engineering?
It's a lot of science actually involved. It's partially engineering, but also a lot of science, because all these algorithms, all these encryption algorithms, they are very scientific based, which is kind of cool. Yeah, at least we have some people who are not only moving blocks on the screens, but doing some real job.
Ideas for future.
Yeah. Maybe you would like to have something in future with HTTP. I don't know.
Something in future with HTTP. I think that in future we don't need ideal future when we don't have the internet speed thing, when something you want to get will be done immediately because internet too fast to measure it.
But we're already here.
We actually will never happen, unfortunately.
It's very long-term plan.
If we're talking about our conversation, we're already here. If we're talking about my game in Dota, I have a huge delay there, and I'm waiting for it. Yeah.
Okay, actually, I don't know plans for I don't know what can be better with HTTP because HTTP3 had a lot of great things implemented, and we'll see how it works.
Okay, I can see that Valentin already would like to have a sleep. Then, guys, thank you for joining. Please subscribe to us on YouTube. You can find us on all social networks: Instagram, Facebook. We don't have Twitter, but maybe later. Yeah, you can join us. We are going to continue record podcast. We have meetups. We have a lot of interesting, fun stuff in our community. Yeah, please join us. Subscribe, I don't know, like, share, repost, whatever you want. Thank you guys for joining. Thank you for sharing your knowledge. It was amazing. See you next time.
Thank you
Thank
for
you.
coming.
Bye.
Bye bye.
Bye bye.
I
Yes.
will eat pelmeni. You try to lose weight.
Yep.
Try to use UDP. I to be honest, I don't understand what you mean real. Will you fight in after show?
Can I just go and follow your order right now?